The ability to draw and manipulate resonance structures is crucial for success in organic chemistry. So I would like to, in this lesson, first review the basics of resonance structures and how they come about, and then talk about the applications, the important molecules in organic chemistry for which we need to draw resonance structures. So the way we need to start thinking about this is to think, suppose we wanted to draw a Lewis structure for the carbonate ion. Well, carbonate ion has molecular formula CO3, 2-, and it has a total of 24 valence electrons. If you add up 4 for carbon and 6 for each of the 3 oxygens, plus 2 more electrons because you have 2 negative charges there, you get up to 24. Okay, so what would be a good Lewis structure for the carbonate ion? Well, we normally put our carbon at the middle because it's going to form the greatest number of bonds, and we bond the 3 oxygens to the carbon. Now, that's taking up 3 of carbon's 4 bonds. We can add 1 more bond and make one of those bonds a double bond. So that's 8 of our 24 electrons in the bonds. We have 16 more to assign, and they all have to go into lone pairs, and we need to make sure we do not put more than 8 electrons around any atom. Okay, so carbon already has 8. It doesn't get any lone pairs. The oxygen at the top has 4. It's got the two bonds that form the double bond, so it can get 2 lone pairs. And then the 2 oxygens down at the bottom only have 1 bond to it, so they need 6 more electrons. So they are going to get 3 lone pairs. Since these oxygens are only forming 1 bond, they need to get the minus charges. Okay, so there we go. We have a Lewis structure for the carbonate ion. Next question is this the only correct Lewis structure we could draw? Well, the answer to that is no. I could have come up with 2 other options keeping the same atomic connectivity. I could have chosen to put the doubly bonded oxygen on the bottom left or on the bottom right. Okay, same atomic connectivity, all that differs is where the double bond is, and now I need to fill in my lone pairs if these are Lewis structures, and put my charges on in the appropriate places. Minus. Okay, so these 3 Lewis structures are equivalent but unique. Each structure has 8 electrons around each atom. They have the same number of bonds, 4, same number of lone pairs, 8, and the same formal charges, 2 negative charges. The only way they differ is in the location of their electrons. Okay, so which of these structures is correct? Well, the answer is all of them and none of them. The reason is that for any one of those structures to be correct, experimental evidence would suggest that a carbon-oxygen double bond would be stronger and shorter than a carbon-oxygen single bond. But the experimental evidence that we actually gain on these molecules is that all 3 carbon-oxygen bonds are the same length, and furthermore, they have the length of exactly 1 1/3 bonds. Okay? So the molecule actually behaves like an average of the 3 structures. So these 3 structures, which are drawn again, are called resonance structures. But it is somewhat of a misnomer because the term resonance in general applies that somehow the molecule is resonating back and forth from one structure to another. That's why it's a misnomer, because it does not actually switch back and forth between the structures. Notice the notation here also that we use a double-headed arrow to denote the resonance structures. This is one arrow that has 2 heads on it, not 2 arrows, one pointing one way and one pointing the other way. In other words, a resonance arrow is a different beast from an equilibrium arrow. You have to make sure that you use your arrows correctly when writing answers to questions involving resonance. Okay, the average structure is sometimes drawn as what's called a resonance hybrid. Okay, so in the case of this average structure, we have 3 full carbon-oxygen bonds, and then the dashed lines here represent partial bonds. Okay, so we have a partial CO double bond in each of these cases, and that's what's giving rise to these dashed lines. We don't always draw the resonance hybrid. In some cases, the drawing of the resonance hybrid is going to look really bad. It's not going to look like a proper Lewis structure because it's the best we could do to indicate such a beast. But sometimes it is helpful for us to draw it, so you need to be able to manage to do that.